Now, for the conservation of energy, okay, for the conservation of energy, conservation of energy states that energy is neither created, energy is neither created nor destroyed, but it can only be transformed to one form, can only be transformed from energy is neither created nor destroyed, but it can only be transformed from one form to another. From one form to another. Okay, under this one, we have the gravitational potential energy. Okay, potential energy, this one is the potential energy. Energy at rest. Now, for the energy at rest, the formula is mass multiplied by the gravity multiplied by the height, where m is the mass, g is the gravity, h is the height. E again is potential energy. M is the mass. G is the acceleration due to gravity. Acceleration due to gravity. H is the height. Now, for the units, wait lang ah. Now, what are the units for the potential energy units? Under the MKS, we have the unit of MKS for the energy. We have joule. This one is under the power. No. MKS for the energy. Wait. Listen. For the MKS, we have Newton meter, mass times gravity multiplied. Now for the MKS, we have joule. Joule is Newton meter. Newton meter. CG is ergs times centimeter. English, foot pounds, and BTU. But remember, 1 BTU is equal to 778 foot-pounds. Now, remember that the unit for the potential energy is joule, ergs, foot-pound, BTU. The conversion, 1 BTU is equal to 778 foot-pounds. Since the potential energy is mass times gravity multiplied by the height, the unit for the mass is in kilogram, and the gravity, the acceleration due to gravity is meter per second squared, and the height is in meter. Now, kilogram meter per second squared is Newton, and then Newton meter is equivalent to joule. Now, for the kinetic energy, we have the kinetic energy. The symbol for the kinetic energy is Ke. Kinetic energy is energy in motion. Okay. Formula for the kinetic energy, that is equal to 1/2 mv squared. where m is the mass, v is the velocity. Okay. The same unit as the potential energy. Now, sometimes you can use the formula of kinetic energy in finding for the potential energy and vice versa. It depends on the given. If the requirement is the potential energy, but the given is velocity and mass, of course, you're going to use the formula of the kinetic energy in corresponding in finding for the potential energy. The same unit, therefore, we have joule, ergs, that is dyne centimeter, BTU, the British thermal unit, and foot-pounds. Okay. Then, now, in finding for the change in kinetic energy is equal to 1/2 m, which is the mass, multiplied by the final velocity squared minus initial velocity squared. Okay. This one is for the change in kinetic energy. KE2 minus KE1 equal to 1/2 mass V2 squared final velocity. Okay, the symbol for the velocity. Okay, we're going to use the symbol, which is squared. For the change in potential energy is equal to mass times the gravity, final height minus the initial. Or PE2 minus PE1 equal to mass times the gravity, H2 minus H1. Okay, now for the internal energy. Okay, the symbol for the internal energy is capital U. Okay, specific internal energy, small letter U. Small letter U. Internal energy, capital U. Small letter u if that is specific internal energy. Now, the internal energy is energy stored within the body. Energy stored within a body or substance. By virtue of the activity and configuration. Right? Virtue. Its molecules. And of the vibration. Within the molecules. Okay, now for the specific internal energy, pag sinabi natin specific internal energy, the same unit as the internal energy, the same unit as the potential and kinetic energy. While if that is under the specific internal energy per unit mass, therefore that would become joule per kilogram, ergs per grams, pounds per pound mass, BTU per pound. Okay. Again, under the specific internal energy per unit mass. Okay. The unit for the energy, then per unit mass. Okay. You have change in small letter u for the specific, that is equal to u2 minus u1. For the change in internal energy, that is u2 minus u1. Next, we have the work. For the work, product of the displacement, okay, from your P61, product of the displacement of the body and the component of the force in the direction of the displacement. Or this one is also known as the energy in transition. Energy in transition. Okay, we have the work non-flow. This one is the work of a non-flow system. This one, the formula for the non-flow works is equal to the integral of P dV with the limits from 1 to 2. Okay, this one is for the work of non-flow. Okay, and always remember the work done by the system, work done by the system, that is positive, while work done on the system is negative. Now we have the flow work. Flow work is W so F. Flow work or flow energy is work done in pushing a fluid across a boundary. Therefore, the formula for the flow work is equal to P times A times L. That is pressure, area, and length. Or that is equal to pressure times the volume. Area times the length is volume. Then, we have also the change in workflow. Flow work or workflow is equal to workflow final minus workflow initial, or that is equal to P2 V2 minus P1 V1. Okay, pressure, volume. Okay, if there's no given volume, instead specific volume, you can use that. Okay, and the unit for the workflow now is per unit mass. Okay, per unit mass. Okay, always remember the energy and the work has the same unit.